We'll discuss about multiplexers and demultiplexers. So initially let us see what is a multiplexer and then we'll move on to the multiplexer. Multiplexer. A multiplexer has n control inputs or selection lines and 2 power n data inputs and one output line. So here multiplexer is a circuit which accepts 2 power n data inputs along with that n control inputs and it will produce only one output. Now here out of these 2 power n inputs, one of the input line is routed to the output and the selection of this input depends on the control inputs or selection lines. Okay, so the data which is present on one of the data inputs will be present on the output and that selection is depends on this particular control lines. Okay, so let us see one of the example of this multiplexer, that is 2 cross 1 multiplexer. Okay, so here 2 cross 1 indicates that it has two inputs. This multiplexer can receive two inputs and produces only one output. Okay, so here as there are two inputs, it means 2 power n. Now the value of n here is 1. Okay, so 2 power 1 is two inputs and n value is 1, therefore the selection line would be only one selection line or only one control line. Okay, now based on this control line, one of the input is selected and that is routed to the output side. Okay, let us see that. This is the representation of 2 cross 1 multiplexer. We can also call it as 2 line to 1 line multiplexer. Okay, and we can also call it as 2 line to 1 line mux. Okay, so here it is receiving two inputs, I0 and I1, and S is the selection line and Y is the output. Okay, now if this selection line is 0, then the value which is present on this I0, okay, the value which is present on this I0 would be routed to the output side. Now Y will be holding the data present on I0. Okay, if this selection line is 1, then the value or data value which is present on I1 is routed to the output side, therefore now Y would be holding I1. Okay, now this is the truth table for the 2 cross 1 multiplexer. Now as you got the truth table, we can easily get the Boolean expression for this. So I have plotted this truth table on the K map and I have got this expression. So Y equals S complement I0 plus S I1. So as I have got the Boolean expression, now I can implement the logic gate design, that is here I need two AND gates for these two terms and then one OR gate. So I have used two AND gates along with an inverter, okay, and then a OR gate. Now this is the logic diagram for this expression. Okay, now this is how we can design multiplexers with the help of logic gates. Okay, now let us see one more example, that is a 4 to 1 line multiplexer where 4 indicates the number of inputs and 1 indicates the number of outputs. Okay, as there are 4 inputs, so it is nothing but 2 power 2 where n value is 2, therefore a total of 2 selection lines are used for selecting any one of the input lines. Okay, here you can see the truth table. S1 and S0 are the two selection lines, Y is the output, and I0 to I3 are the input sources. Okay, if S1 and S0 are 0 0, then the output would be I0. In the same way, for 0 1 output would be I1, and for 1 0 output would be I2, and the last combination 1 1 output would be I3. So and this is the logic diagram of 4 to 1 line multiplexer, and it is implemented by using logic gates. Okay, now let us see an application of the 4 to 1 line multiplexer, multiplexer. So here we have a speaker set, and now this speaker set is getting the input from 4 sources. Okay, so this speaker set, at a time this speaker set can respond to only one of the source, so that is why I have used one multiplexer here which is having two selection lines. So based on these two selection lines, any one of the source is selected and the output of that particular source will be given as an input to the speaker set. Okay, so this is how we can use the multiplexers in different kinds of applications. Now let us see our next concept, that is demultiplexers. Now these demultiplexers will perform the converse operation of the multiplexer. Okay, this circuit will accept n control inputs along with one data input and then produces 2 power n outputs. Okay, so here it receives only one input. Now that input will be routed to any one of the output lines and that output line is selected with the help of these control inputs. Okay, let us see that with an example. 1x4 demultiplexer. Here 1 indicates the input and 4 indicates number of outputs. As there are 4 outputs, therefore there would be a total of 2 selection lines. Okay, and this is a truth table for demultiplexer. As you can see, A and B are the selection lines, and X, Y, W, X, Y, Z are the outputs. Okay, and this is what the expression that we have got. Now after getting this expression, now we have to plot this expression by using logic gates. Okay, so this is how we have plotted that expression, or into by using logic gates, and this is the representation of the demux. Okay, and a typical application here, I have a computer which is acting as one of the target device, and there are totally four other destinations. Now this computer has to use any one of the sorts, so that is selected with the help of these selection lines, and by using that it would be selecting any one of the sorts. And this is one more example. So initially at the source, I am just going with multiplexer, where one of the data is selected and that is transmitted through the bus, and at the destination I am going to select one of the destination channel. To that I am going to route this particular data. Okay, so this is how we can use multiplexers and demultiplexers in communication. Thank you.